Hello guys, today I speak about the electromagnetic spectrum, structure of matter. Introduction. The electromagnetic spectrum is the range of all possible electromagnetic radiation. The spectrum of an object is the characteristic distribution of electromagnetic radiation that object. Thus, the high frequency electromagnetic waves having a short wavelength and high energy. Low frequency waves have a length of low wave energy. We have two. The frequency is the number of waves that pass at a given time. Generally, electromagnetic radiation is classified by wavelength, radio waves, microwaves, infrared, and visible region. We perceive as light, ultraviolet, X-rays, and gamma rays. We have two. The wavelength is the distance from crest or valley and valley. We cite that the wavelength is inversely proportional to the frequency. Now see the different types of a spectrum according to its wavelength. Radio waves are usually used by antennas of appropriate size, with wavelengths within the limits of 100 meters to about 1 millimeter, are used for data transmission. For example, television, mobile phones, MRE, or wireless. Radio waves can carry information by varying the combination of amplitude, frequency, and phase of the wave within a frequency band. Microwave. The super high frequency is HF and extremely high frequency EHF of microwaves are also followed in the frequency scale. Microwaves are short enough to employ tubular metal gauge waves resonant diameter. Microwaves are absorbed by molecules having a dipole moment in liquids. In a microwave oven, this effect is used to heat the food. Microwave radiation of low intensity is used in Wi-Fi. Infrared. The infrared part of the electromagnetic spectrum covers the range from about 300 GHz to 400 terahertz. Can be divided into three parts. For infrared, the bottom of this range can also be called microwave. Water in the Earth's atmosphere absorbs this radiation so strongly that keeps the atmosphere opaque, affecting mid-infrared. Can radiate strongly in this range. Is absorbed by molecular vibration when the different atoms in a molecule vibrate about their equilibrium positions. Nerve. Infrared. Physical. Processes that are relevant to this range are similar to those of visible light. Visible. The infrared frequency is above that of visible light. This is the range in which the sun and stars similar to it emit most of their radiation. It's probably not a coincidence that the human eye is sensitive to wavelengths that the sun emits most strongly. Visible light are absorbed and emitted by molecules and electrons in atoms move from an energy level to another. Electromagnetic radiation with a wavelength between about 400 nanometers and 700 nanometers is detected by the human eye and perceived as visible light. Ultraviolet. The next frequency in the spectrum is the ultraviolet or UV. Radiation is of a wavelength is shorter than the violet end of the visible spectrum, being very energetic. UV radiation can break chemical bonds, making exceptionally Reactive molecules of using them, changing their behavior. Some, for example, are caused by the harmful effects of UV radiation on skin cells and might cause skin cancer if the radiation damages the molecules of complex DNA in cells. The sun emits a large amount of UV radiation, which could quickly turn Earth into a barren desert if it were not. For the most part, is absorbed by the ozone layer of the atmosphere before reaching the surface. X-rays. The hard X-rays have wavelengths shorter wavelengths than soft X-rays, generally used to see through some objects as well as for high-energy physics and astronomy. Neutron stars and accretion disk around black holes emit X-rays, allowing us to study them. X-rays pass by most substances, and this makes them useful in medicine and industry. They are also made by stars and especially for some types of nebulae. X-ray machine works by firing a beam of electrons on an objective. If electrons are fired with enough energy, X-rays are produced. Gamma rays are the most energetic photons, and the lower limit of wavelength is not known. They are useful to astronomers in the study of objects or regions of high energy and are useful for physicists thanks to its penetrating capacity and production of radioisotopes. The wavelength of the gamma rays can be measured with great accuracy by Compton scattering. To finish, not precisely defined between the bands of the electromagnetic spectrum limit. Some types of radiation have a mixture of the properties of radiation found in two regions of the spectrum. For example, the red light to infrared radiation appears in some chemical bonds by resonate. Thanks for luck.